We're going to be looking at projectile motion. A projectile is an object that moves under the force of gravity. So examples include throwing a ball or firing a cannonball. When solving problems that involve projectile motion, there are various rules that you need to remember. And the first rule is that the horizontal and vertical motion are independent of each other, so must be considered separately. And that's because we're dealing with vector quantities. Remember, vector quantities have direction, so motion that are perpendicular to each other, so horizontal and vertical motion, have no effect on each other. This diagram is showing you a horizontal projection where the green arrows represent the velocity vectors in the horizontal direction and in the vertical direction. And so the second rule for projectile motion is that the horizontal velocity is constant, and that's because there's no force or acceleration that acts in the horizontal direction. We are assuming in this case that there's no air resistance that is acting on the projectile. The third rule is that the vertical velocity changes due to the acceleration due to gravity. So if the projectile is moving upwards, then the vertical velocity will decrease because the projectile will be decelerating upwards. But if the projectile is moving downwards, then the vertical velocity will increase because the projectile will be accelerating due to gravity. And the fourth rule is that we can use the Suvat equations for the vertical motion, and that's because vertically we have a uniform acceleration due to gravity. However, for the horizontal direction, we can use the equation for constant velocity, which is S equals vt. A projectile will be moving horizontally and vertically at the same time, but these motions do not depend upon each other. Here we have a ball that's being projected horizontally, and you can see that horizontal velocity is constant. The ball travels equal distances in equal times horizontally. However, vertically, the ball is accelerating due to the force of gravity, and so the vertical velocity is increasing. So the ball is covering a greater distance per unit time each second. This diagram is showing you a ball that has been projected horizontally, and at any given moment in time it will have a horizontal displacement of SH and a vertical displacement of SV. And to determine the horizontal displacement, because the ball is moving with a constant velocity horizontally, then we can use the equation for constant velocity, which is S equals ut. And u is the initial velocity of the ball, which was in the horizontal direction, and so that velocity is constant. When looking at the vertical motion, we can use the Suvat equations. So the displacement vertically is our SV. The initial velocity vertically is 0, and that's because the ball has been projected horizontally, so there's no initial vertical velocity. The final vertical velocity will denote as VV. The vertical acceleration will be due to gravity, so will equal G. And the time will be T. And it's the same time T that can be used horizontally and vertically because time is a scalar quantity. So it does not depend on direction. So in the same time T, the projectile has moved vertically as well as horizontally. In this case, we have a ball that is projected at an angle. So using trigonometry, we can determine the horizontal velocity of the ball, which will be u cos theta, and the initial vertical velocity of the ball will be u sine theta. And at any given time, the ball will have moved horizontally with a displacement of sh and vertically with a displacement of sv. And so to determine the horizontal displacement, we will use the equation for constant velocity. So S equals ut. And the horizontal velocity is given by u cos theta. So the horizontal displacement will be u cos theta multiplied by time t. Vertically, we can use the Suvat equations. So the vertical displacement is our SV. The initial velocity vertically is u sine theta. Our final velocity vertically we will denote as Vv. The vertical acceleration is due to gravity, but as the acceleration due to gravity acts vertically downwards, and we took the initial velocity of the ball to be positive vertically upwards, our acceleration will equal minus g because it's in the opposite direction of the initial velocity. And the final quantity will be time t. And it's important to note that at maximum height, the vertical velocity will equal 0, and the horizontal displacement will be half of the maximum horizontal range, and that's assuming the path is symmetrical. So just a reminder, horizontally the velocity is constant. There's no acceleration force that acts in the horizontal direction. Vertically, the velocity changes due to the acceleration due to gravity. So upwards, the vertical velocity decreases because the projectile is decelerating due to the force of gravity. At maximum height, the vertical velocity is 0. However, it still has a horizontal velocity. And then the vertical velocity will increase because the ball is accelerating downwards due to gravity. Everything that we've looked at so far has assumed that there's been no air resistance acting on the projectile. So the only force is its weight, its force due to gravity. However, with air resistance, the path of the projectile is different. Air resistance or drag opposes the motion of the projectile. So horizontally, the projectile will decelerate, so the horizontal velocity decreases, so the horizontal range will be less. Vertically, when the projectile is moving upwards, the air resistance will act with the weight to oppose the motion of the projectile, so the deceleration of the projectile will increase, so the maximum height will be less. And when the projectile is moving vertically downwards, the air resistance will oppose the weight and so decreases the acceleration of the projectile. And so the air resistance will also reduce the time of flight. Here we have a ball that will be dropped at rest vertically. And here we have a ball that will be projected horizontally. And you can see they will hit the ground at the same time, and that's because they have the same vertical motion. They have the same initial vertical velocity, which is 0. They're falling from the same height, and they have the same acceleration due to gravity.